We're now going to use the tree class that we just wrote into an interesting problem through which we will become again much more familiar with using arrays and how we can use arrays. We want to create a new class and we will call it TreeTracker. Inside the class we want to be able to create random tree objects. What does it mean they are going to be random? Well, remember what kind of characteristics a tree has. It has three variables: a serial number, the circumference, and it also has a species. For each tree we are going to create, we want to be picking a random value for the circumference. We also want to pick a random species for every tree that we're going to create. How can we do that? Well, this is one way we can do it. Think of 4 kinds of trees you like. And then every time you create a tree, select the species randomly from those 4. Now, after we have created our trees, we want to store them in an array and print out the information using the describe method. You probably have noticed that I did not mention the serial number being created randomly. For that, we can use any number we want. For example, if we are creating the trees in a for loop, we can use the index variable of the for loop, the control variable of the loop, as the serial number for every tree that we create. This is up to you. You can implement it in any way you want. You can see what is our goal, what we want to illustrate with this example. And I will be giving you one more hint on how to create these random values. Here you can see the API for the random class, which is part of the java.util package. With this class, we can create what is called pseudo-random numbers. So numbers that, from a mathematical perspective, they are not random, but they are random enough for most of our applications. You can see that we can create a random object through the constructor and then call all of the methods that are provided to us through that random object. Of particular importance for this example that we want is the next double method that will give us a uniformly distributed double value between 0 and 1. And you also would like probably to take a look at the next int and the next int with a bound method. Here is the TreeTracker class that we have just started. It is a program. It has a main method so that we can run it. We have completed almost all of the things that we need except for 2 lines, lines 14 and 15, that we will actually complete together. Let's take a look at what we do. We said that we want to be creating random new tree objects. And we will be storing these objects into a tree array. And we have in mind to actually create 100 new tree objects. Because we want to be creating random numbers, pseudo-random numbers, as we saw through the random class, we have created an random object. As I mentioned before, what we're going to do for the species is that we will pick 4 species of trees, 4 kinds of trees: walnut, apple, orange, and fig. This is just to our liking. And then every time we create a tree, which happens inside the for loop that we will see in a minute, every time we create a tree, we pick the species for this tree randomly from the string array. After we have the species and the circumference, then we are creating the constructor. We are calling the constructor, and we are providing these 3 values. The serial number is just whatever value we get from the iteration of the loop. D and species we will have to randomly generate, and then we store this new tree object to the tree array, to a specific position in the tree array. And finally, we will print information about the tree that we just created through the describe method that you probably remember from writing before when we wrote the tree class. So now there are two questions so that we complete this class. How are we going to create, to give a random species to this tree? What do we need to do? I mentioned when we were talking about the random class that there is a next int method in the random class, so we can invoke it through R. And as you can also see from the hint that IntelliJ IDEA provides, there is a next int that takes a bound. What is that bound? We can say that we want you to return to us an integer that will not be greater than this particular value. Go back to the API if you do not remember what next int with a bound does. For instance, here we could say that we want the length of the species array, of this S array, to actually be the upper bound. So this number here will be the random index that we can use to go inside the S array and pick one of these values. Next int again will generate a value that is from 0 with upper bound s.length. And this upper bound is non-inclusive. So if we say we want s of this particular value, the index will be our random number that we want, and we will randomly pick one of these strings. So this is one way that we can have a pseudo-random species identifier. Similarly, for the double, we can use the next double method from, again, the random class. Now the next double method will return to us a number that is not greater than 1. And for a circumference of a tree, which is the way that we want to use D, that will probably not make much sense. So we can, for instance, multiply this number by 100. And then our implementation for the tree tracker will be complete. Here is the output of the program that we have run. We have created 103 objects and also printed through the describe method the information for those. So you can see double values for the circumference. You can see that the species of the tree varies among the 4 that we chose, and also that the numbers of the trees go up to 99. They go from 0 to 99. Now, if you run this program yourself, you will also find out that, for example, the species is randomly distributed among these 4 values that we chose.